Well, hello everybody. It's 2 o'clock, and let's start this seminar on blue carbon. I will start by some housekeeping rules. So please make sure your name is clearly entered. So when you ask a question, we know who you are. And to ask a question during the discussion, please use a Q&A button, which is on the Zoom just in your panel. Let us know which organization and country you are from, and the discussion moderator will select question to be addressed. For any Zoom technical support, use the chat, and some of the European Mind Board Secretariat will help you. This webinar is being recorded, and it will be made available on the European Mind Board website, where you have the address on the screen, and also on the European Mind Board YouTube channel, where you have also the address on the screen. So today, as a chair of the European Mind Board, I'm very happy to introduce this webinar presenting the recently launched EMB Policy Brief number 11, which is Blue Carbon Challenges and Opportunity to Mitigate the Climate and Biodiversity Crisis. This online webinar is due to be 1 hour and a half long and will include a presentation of the document and its main messages by working group members. And we will hear about this subject from Hans Otto Partner, from AVI, Alfred Wegener Institute in Germany, after Peter Landschutfer, sorry about mispronouncing your name, from Vlies in Belgium, Nathalie Hicks from the University of Essex, United Kingdom, and Jean-Pierre Catuzot, CNRS from the Sorbonne University, and INDRI in France. After this presentation, there will be a response to the document by the European Commission, and I thank Nikos Zanpoukas, which is from the DG Research and Innovation, and the unit LC Ocean and Seas, who will give this response to the document. And after that, we will have a panel discussion with opportunity for Q&A, and it will be moderated by Sheila Emmans, which is the EMB Executive Director. The Blue Carbon document, Policy Brief number 11, was launched during the Ocean 2023, held in Vigo, Spain, the 20 November 2023. This EMB Policy Brief described different types of benefits of blue carbon ecosystems. We can say that blue carbon ecosystems are a nature-based solution that can help mitigate the climate and biodiversity crisis. In this document, we can find discussions about uncertainties and challenges for using blue carbon ecosystem as a climate change solutions. This document also highlights a wider role of the ocean in mitigating climate change through the carbon cycle, and it ends the reflection with key research and management recommendation. This next slide, the working group was chaired by Sheila Emmans, the executive director of the European Mind Board, and the working group members were Jean-Pierre Catuzot, who will present some of the results today, Nathalie Hicks also, who is there with us today, Peter Landschutfer, which is also present with us today, Greet Nieuwkermans, unfortunately not there, and Hans Otto Partner, who will also give a talk today on the subject. I would like to thank the external reviewer, Sophia Johannesson, Adrian Martin, Pierre Tailladard, and Philippe Williamson. So to start and present the blue carbon document, we will have by order Hans Otto Partner from the AVI. I've already said that, and to stop talking too much, I will leave the floor directly to Hans Otto to give a presentation of the blue carbon document and some highlights on that. And Soto, the floor is yours. Thank you very much.
Yeah, thank you very much, Jill. And just to start our presentation with the opening slide, I would highlight Gilles has already introduced the authors and the external reviewers and the people who have helped us put this together. And I would like to highlight here that along the way, we have not only addressed the carbon itself, but have also addressed the climate and biodiversity crises together, following some insight from joint efforts of IPCC and IPBES to see the links and between these two existential crises of our planet. So please be curious about what we are going to tell you. And the next slide, please. Will tell you what is covered in the document. We actually ran into the situation that we had to reinvestigate the definition of blue carbon and to widen it a bit based on recent insight on where the carbon is actually stored in the marine realm. Then we are talking about the benefits of blue carbon ecosystems. And we are talking about the pathways. How does the carbon actually end up where it is being stored long term? And the time scale here is very important. This includes the role of the ocean and its creatures in the carbon cycle, going from plankton to animals and including plants. Then we focus our lens a bit on Europe and talk about examples and benefits of blue carbon ecosystems for our continent. And we will address some uncertainties and questions on blue carbon ecosystem conservation and restoration when it comes into light as a potential climate change solution. And we conclude with a summary and recommendation. It's certainly not a scientific paper or manuscript or publication that we are presenting, but it's really a high-level overview of all the different aspects. And in that respect, it's we think it's quite unique, and it's written to be understandable by a wide audience. Next slide, please. So when it comes to the definition of blue carbon, there is a traditional definition which focuses actually on more the coastal vegetated ecosystems, where in mangroves, tidal marshes, seagrasses, the carbon is stored by these organisms and in the sediments and helped by these organisms. Now we think it's time to expand that definition and also include shelf and offshore marine sediments, because these cover wide surface areas and also are places where carbon is buried and stored. And to bring it there, the biological carbon cycle needs to be considered, and that must include also the deep ocean, and it must include the whales and the fish stocks, because they are providing important pathways for the carbon to be stored then in the marine sediments and including the deep sea. Kelp and macroalgae can also be mentioned here, which absorb CO2, but they do not bury it. And calcifying organisms to be considered. They can trap and store carbon in sediments, but during the calcification process, actually there is an emission of CO2 to the ambient water, which is also something that is complicating the overall picture. Next click, please. So in this policy brief, we have defined blue carbon as the carbon stored in coastal vegetated ecosystems with rooted vegetation, in line with the original definition, and then include also the marine coastal, continental shelf, and offshore sediments for a more comprehensive picture. And the most important issue here is the long-term storage of carbon. Next slide, please. So it is certainly what is happening in these ecosystems in terms of protection and restoration of blue carbon ecosystems. It is a nature-based solution. It will contribute to some extent to climate change mitigation, but the emphasis here is that it is and can only happen on the long term, and there is a limited contribution. We will get to that. The co-benefit of this approach is that there is a conservation and possibly restoration in some places of marine biodiversity, in both in terms of habitat and in terms of food provision. And there are also co-benefits for humankind. The protection and restoration of blue carbon ecosystems will stabilize livelihoods. It will yield and provide marine natural resources. It will protect coasts against storms and flood, and support other societal needs such as food security from the ocean. Next, please. And as I said, there are limitations to this, and certainly the one important limitation is the available space. And the next limitation to be called out is the rate of carbon storage. If you look at its maximum potential to contribute to mitigation, it only equals 2% of our current global emission rates for carbon dioxide and this and other greenhouse gases, so carbon dioxide equivalents as we call them. And the important aspect here is this carbon storage capacity depends on marine life being functional. And when we say that climate change can reduce effectiveness, this is an important aspect. Ambient and global warming will actually constrain the capacity of ecosystems to bind and store carbon dioxide. And in that respect also, when we are losing coastal ecosystems due to sea level rise, there's a loss of space, and together with these negative impacts of warming and also of drought in some instances, this can reduce the effectiveness of forming and storing blue carbon. So protecting life and protecting biodiversity is an important precondition for blue carbon formation to be functional. And therefore, it is definitely not a replacement for the reduction in greenhouse gas emissions. In actual fact, reducing greenhouse gas emissions is an essential precondition for functional blue carbon ecosystems and for their continuing capacity to store the carbon away. And these emissions, the emissions reduction, and this is a large call in our present time, the emissions reduction needs to be sufficiently ambitious and sufficiently fast to keep global warming close to 1.5 degrees above pre-industrial. And we all know how much of a challenge that is to our policymakers and to our societies. And with that, I hand over to Peter for the next slides.
Thank you very much, Hans Otto. I'll continue from here. Okay. And I would like sort of to, in the next part, sort of look a bit more on a sort of zoom out a little bit and look more in the carbon cycle as a whole in general. And as we know, we're facing times of very strong perturbations of the carbon cycle. So in fact, today we have more than 10 billion tons of carbon emitted due to fossil fuel emissions, land use change, etc. And we equally know that only about half of it stays in the atmosphere. And the ocean plays an important role in mitigating climate change, as it currently takes up about 25% of these CO2 emissions each year. And this number, this 25% uptake by the ocean, has been relatively stable for now quite a few years and decades. And this uptake really depends on one hand on the ocean's ability to absorb carbon dioxide from the atmosphere, so through gas exchange, which is on the one hand driven by the kinetic transfer through the SE interface, but most importantly, driven by the concentration difference of carbon dioxide at the SE interface, or the partial pressure difference. And that one is in second hand be very strongly influenced by the transport and storage of carbon away from the surface through the biological carbon pump and through ocean currents. So we in general speak here from the carbon pumps that sort of help us help the ocean sort of taking up carbon dioxide from the atmosphere. But what we also know is that the ocean, as steady as this sort of uptake has been in the past decades, that this will not continue endlessly. So we know that this uptake, this 25% uptake of all emissions that we currently see on an annual basis, will diminish as we go into the future with more greenhouse gas emissions. This, on the one hand, has to do with the ocean's buffer capacity diminishing due to the process of ocean acidification. And on the other hand, also due to other physical mechanisms playing a role, for example, ocean warming and the decrease in solubility. So a second thing that is sort of very important to consider when looking at the inorganic carbon cycle is that CO2 that is in the seawater and that is sort of brought away from the surface into the deeper ocean can actually re-enter to the atmosphere as it sort of as the ocean ventilates, and deep sort of carbon that is stored in the deep ocean re-ventilates to the surface and can actually be re-emitted into the atmosphere. And therefore, sort of, but carbon removal timescales actually correlate quite strongly with depth, and I'll get to that in the next slide. But to summarize the slide, what's important here is that the uptake of CO2 by the ocean is critically important in general for climate change mitigation. Next slide, please. Now, going a bit more specifically into the biological carbon pump, and talking about the transport of organic carbon from the surface to deep. We know this is mainly a process driven by phytoplankton, which converts CO2 into organic carbon through photosynthesis. And this carbon is then further transferred to other animals through the food webs. And part of this carbon reaches then also the twilight zone. So we're talking about the depth of 100 to 1,000 meters through sinking particles, vertical animal migration, or physical mixing. But we also know that most of the carbon that is also then converted back into CO2 and nutrients at this depth through remineralization. And only a small proportion reaches deeper waters where it can be stored for a much longer timescale, so timescales of 100 to 1,000 years. And an even smaller proportion is stored in the sediments, where we then really talk up at carbon burial for millions of years. So the biological carbon pump helps in building blue carbon ecosystems, but yearly contribution is actually quite small. Next slide. And now coming a bit more into the carbon removal timescales in the open ocean, which is dependent on depth, as already mentioned. So in the surface ocean, so we're talking about 0 to 100 meters, we have removal timescales of months to years. So it's actually the effect of carbon removal is rather small in these depths. When we reach the twilight zone, we have carbon removal timescales of 10 to 100 years. So the timescale essentially strongly increase. But when we reach in the deep ocean, where we have sort of a depth of more than 1,000 meters, we have really talked about removal timescales of 1,000 years and longer. And once the carbon reaches the seafloor, the removal timescale goes up to 1 million years. But we also see that the amount of carbon, this depth at the seafloor, really decreases to about 2.2 billion tons carbon per year. And also, which is also worth mentioning, is that bottom trawling and dredging might actually re-release some of the carbon that is stored in the sediment back into the water column. But at the moment, the uncertainty is too large to make robust estimates of that. Next slide, please. Next, I would like to go a bit into detail about the many uncertainties that we still face in the ocean carbon cycle, and particularly with regards to the biological carbon pump and the carbon budget. Overall, we can say the marine carbon cycle is complex That is a given. And we have uncertainties on the amount of carbon that is exported annually from the surface to the very deep ocean. There is quite an uncertainty about the influence of the carbon counterpump, which Hans-Otto has already introduced, which counters the effect of the biological carbon pump and increases CO2 actually in the surf water by through the process of calcification. We've got an uncertainty on how climate change will affect actually the biological carbon pump, but also the carbon counterpump. And there's an uncertainty in the role of species such as whales in strengthening the natural carbon cycle, for example, for fertilization by whale excrements. And compared to the open ocean, we've got much larger uncertainties in the coastal ocean and coastal carbon budgets. And as a final statement, we'd like to mention that carbon that is buried in deep water sediment is usually less sensitive to climate change, also through the processes that Hans-Otto has in part already mentioned. So the ideal storage place for excess anthropogenic carbon emitted for multiple centuries would actually be the deep sea sediments. And with this, I pass on to the next speaker, which is Natalie.
Thank you very much. So I'd like to give a quick overview of some of the blue carbon ecosystems that we find in Europe. Surprisingly, mangroves are not one of them, but we've included them in our list because they make up the 3 original traditional definitions of blue carbon ecosystems, and they're probably the best understood example of blue carbon. Now, we don't have any mangroves in mainland Europe itself, but we are aware there are a number of mangroves in overseas territories and tropical and subtropical regions. Mangroves, like many of our other coastal blue carbon systems, also provide a number of co-benefits, and this includes providing habitat to promote and enhance biodiversity, but also food provision and coastal protection. Now, seagrass meadows we do get in Europe, and we get roughly 2 different types of these, depending on their location. So in the Mediterranean, we get Posidonia oceanica, which is a larger species of seagrass, and it tends to be subtidal. It's also the one that a lot of our seagrass carbon estimates and knowledge are based on, whereas elsewhere towards the sort of northwest European shelf, we see smaller species, the Zostera species. These can be intertidal and subtidal, and we're starting to build our knowledge base and understanding how they fit and play a role in carbon, as well as compared to the Posidonia species. Like mangroves, they're also really important not only for blue carbon storage, but also for biodiversity, and they provide a habitat which serves as a nursery grounds for many commercial species such as cod and plaice. Next slide, please. One of my favorites are salt marshes. We have an extensive number of salt marshes in Europe. These are always intertidal. Their very name, salt marsh, means they exist on the edge of the terrestrial zone, but into the intertidal. And so they're frequently washed with tides, and you get tidal zones within them. In many cases, they may be adjacent to grassland, which could be natural or grazing grassland. And the salt marshes we have now are only a small proportion of what we historically used to have. And this is a result of land reclamation, where land was historically drained and used for something else, quite often agriculture or livelihoods living on. Salt marshes, we know as well, provide a number of co-benefits. So this can include biodiversity, but also because they're often found on soft sediment coastlines, they provide a buffer from a lot of our storms. So they provide coastal defense and flood protection. And then the sort of newer blue carbon ecosystem that we've included within this policy brief are marine sediments. And this covers everything from coastal sediments onto our continental shelves, such as the North Sea, and also offshore sediments. And this includes muds and sands. It also includes intertidal mudflats, which we don't often think about when we talk about blue carbon, but inevitably where you find one of our blue carbon ecosystems, there will likely be a mudflat adjacent to that. Marine sediments are also the least understood of our blue carbon ecosystems. So the accumulation rates are not really well understood and how long it takes for them to sequester and store carbon, but we know that those carbon stores are extensive, although most of this carbon is sourced from other habitats. Unlike any of the other blue carbon ecosystems I've already discussed, unless they're coastal sediments, they tend not to directly capture CO2 themselves through photosynthesis due to their depth. But they're the least understood of our habitats. Okay, next slide, please, Anna. But what is important to consider when we talk about blue carbon ecosystems, and as I presented them today, I presented them as their different habitats, they are often connected to each other. So you may often find a salt marsh that is adjacent to an estuary that has a seagrass meadow and also a nearby mudflat. And so carbon not only becomes sequestered in the sediments, but it also fluxes and flows and moves between them. And this has implications for restoration and management. So we should be thinking away from preserving or focusing on just one habitat and looking at that seascape connectivity between them. And this ability to effectively manage our marine habitats will help protect some of the carbon stored within them, but also importantly, the co-benefits that they provide. I'll hand over now to Jean-Pierre.
Thank you, Anna. So Anna presented the benefits, the multiple benefits of blue carbon ecosystems and therefore the benefits of their conservation and restoration. Now, there is of course a lot of uncertainty in this area. These uncertainties are due to the limited surface area available in coastal environment for blue carbon restoration. The reason is, of course, that some of the, well, it is estimated that 50% of the blue carbon ecosystems have been lost since the Industrial Revolution. And of course, some of those areas where the vegetated ecosystems were lost cannot be restored because they are now occupied by roads, by harbors, or by cities. So the amount of the suitability is low. There is also the issue of suitability of substrate, depending on the granulometry of the sediment, a species could be established or not. The second reason for high uncertainty is related to carbon accounting, because ultimately, concerning mitigation, it is some carbon credits are given to projects which restore blue carbon ecosystems. But to provide carbon offsets, one needs to be quite certain of the amount of carbon which has been stored as a result of a restoration project. And it is, as we will see in the next slide, it is very difficult to make this carbon accounting, which is essential to demonstrate the benefits of climate policy actions. So concerning therefore the uncertainties in terms of accounting, there are many. Perhaps the most critical one is the fact that there are very large variations in the burial rates of carbon. A mangrove can store much less or much more carbon than mangrove forest elsewhere. And also within the same mangrove forest or seagrass bed, there is a very large diversity of rates at which carbon is accumulated. Part of it is due to the disturbance of sediment by burrowing animals, which affect sediment dating. It's easy to measure organic carbon in the sediment, but one also needs to know how much time was needed to store this amount of carbon. And measuring the time is often quite difficult because of burrowing animals. Also, some of the carbon that is buried in the blue carbon ecosystems, it is actually not locally produced. Some of it, up to 90%, comes from elsewhere and is trapped here, not as a result of the restoration directly. Another issue is the fact that the conditions that are favorable for the storage of carbon, and that is anoxic conditions where there is very little or or not at all oxygen in the sediment, those conditions are also favorable for the production of methane and nitrous oxide, which are very strong greenhouse gases. So this has to be taken into consideration for carbon accounting. Then there is the long-term integrity of restored and blue carbon habitats. That is because climate change has a strong impact on blue carbon ecosystems. And let me just provide one example of a mangrove forest, a huge mangrove forest in the northeast of Australia, in Queensland, which I think it was in 2015, died. 40 million trees died. It's enormous, the scale of this loss, which was due to an El Nino effect. So if this mangrove would have been the result of restoration, and if carbon credit would have been given to this project, you see that all the carbon, or a lot of it, could go back to the atmosphere. So it really shows that the permanency of carbon storage is not at all a trivial problem to estimate in the long term, because also there are human pressures. There are many countries in Southeast Asia where mangrove forests are cut down to make facilities for aquaculture of shrimps, for example. And of course, when a system has been devoid, I mean, the trees have been cut down, all the sediment which accumulated carbon in the past decades, this carbon will become exposed to atmospheric oxygen and has the potential to be respired and therefore CO2 released to the atmosphere. Next slide. In summary, there are many uncertainties impacting carbon accounting. It is therefore absolutely critical to continue investigating the storage of carbon in blue carbon ecosystems. It will be absolutely foolish to rely, of course, on blue carbon ecosystems to offset current and continued emissions. But as Natalie said, there are extremely good reasons to continue protecting them and restoring those ecosystems, which have a very small impact globally on in the carbon cycle, but they provide many co-benefits, and many were mentioned: biodiversity conservation, food security, coastal protection. So the long-term contribution to climate change can be significant once emissions are strongly reduced. I also want to highlight the fact that this 2% of present-day CO2 emissions being stored in blue carbon ecosystems, so it's a global number, but it can be much more at a national level. For example, Indonesia, which has a lot of mangroves and seagrasses, it will be much more than 2% of the annual emissions of Indonesia or other countries. So protecting and conserving blue carbon ecosystems is a very good idea and something which must be pursued. They will contribute to solving both the biodiversity and climate change crisis. But of course, there is no excuse not to reduce emissions of greenhouse gases. That will be critical to keep global warming to as close as possible to 1.5 degrees. Also to ensure the permanency of blue carbon ecosystems. Next slide. So the policy brief, which I strongly recommend you download on the website of the European Marine Board, has many recommendations for funders and for research. The first one, of course, is to reduce the uncertainties about the amount of carbon removed and stored by blue carbon ecosystems. It is essential to have a crediting and offsetting process that is honest. We don't want to have the same issues as on land with the REDD+ scheme of the United Nations framework for climate change. One needs to quantify as best as possible the production of methane and nitrous oxide, which can be a result of coastal restoration. One needs to understand the dynamics of offshore carbon stocks and sequestration and the potential impact of human activities, such as trawling and deep sea mining, which can remobilize the carbon into the water column and eventually to the atmosphere. Of course, to improve our understanding on the global ocean carbon budget, it is absolutely essential to continue to have an active monitoring and many observations of carbon, the stocks, the fluxes, the process rates, both on long-term temporal and also large spatial scales. That is essential components to better understand the biological carbon pumps and also the counter-carbonate pump, as well as storage in the sediment. So sustaining a strong observation program is essential to better parameterize all the processes involved, and they are quite numerous, but in the carbon cycle models, and that is an essential step to continue. But we don't have to wait for a lot of progress to be made. We can act today to conserve and restore blue carbon ecosystems. It's a no-brainer. Finally, it's important to promote interdisciplinary studies. One must include environmental scientists, social scientists, and engineers to work on blue carbon ecosystems, their societal benefits. That is a very good example of, we could add also policy scientists, you know, it is essential to have an interdisciplinary approach in this area. I believe I hand over to Sheila, maybe, or who's the next? No, Nikos, sorry.
Thank you very much. Thank you, Jean-Pierre. Thank you to all of you, or the four presenters, Ansoto, Peter, Nathalie, and Jean-Pierre, for giving this presentation. And now we have the chance to have Nikos Zanpoukas, which is a policy officer at the European Commission, DG Research and Innovation, and from the unit of LC Ocean and Seas. And the European Commission is, as most of our webinar and when we have our presentation and briefs, give a response to that. So Nikos, I give the floor to you for the response on the document. Thank you, Nikos, for attending this meeting.
Thank you, Gilles. And let me first thank the European Marine Board for inviting the European Commission, DGRTD, to this launch event, and of course, congratulate the authors of this policy brief. We appreciate very much and we support very much the work of the European Marine Board because it always provides timely, comprehensive, and concise input to marine research and innovation policy making. And this is what we do in DGRTD. We develop research and innovation policy in my unit for marine research. Actually, we often showcase the policy briefs and other reports that the European Marine Board produces. We showcase them as best practices that bring forward marine research issues to the appropriate policy makers, both inside the Commission and also outside in member states. I can say that previous reports of the Marine Board have been influential in identifying research priorities, and we believe that the same goes for this policy brief on blue carbon and also its recent sister publication on coastal resilience that emphasize the need for ecosystemic understanding for climate adaptation, resilience, and ecosystem-based management in dynamic systems such as the marine ecosystems are. Of course, the carbon cycle is a fundamental part of the biochemistry of life, biogeochemistry of life, the functioning of the ecosystems, and we see research and applications of blue carbon as a win-win solution for both the climate and biodiversity objectives of the European Green Deal, that is the vision of our Commission to make our continent carbon neutral. And blue carbon, it has already been a high priority for DGRTD while we were developing the first work programs of Horizon Europe. That is the European Program for Research and Innovation, what we develop in DGRTD. We already had in the first year several topics that are relevant. We had a very basic topic on understanding the ocean carbon cycle. We had a topic on restoration of natural wetlands, floodplains, and other such ecosystems, on carbon and biodiversity-rich ocean and coastal ecosystems in Europe and also in the polar regions, about valuing coastal and marine biodiversity and ecosystem services. about observing and mapping biodiversity and ecosystems, about cumulative stressors, direct, indirect, how to assess them, how to predict them, how to predict the integrated impacts of such cumulative stressors, about measures and management of coastal and marine ecosystem restoration, including socioeconomic considerations, about maritime special planning, specifically for planning and identification of marine protected areas, about restoration, particularly of deep sea habitats, about marine and coastal infrastructures and how to use them as hybrid blue-gray nature-based solutions. So it's not the first time we hear, and we try to do something in Horizon Europe for blue carbon. In addition to the traditional topics that I mentioned, we now have a new powerful way to do research, but not only research. The mission, of course, to restore our oceans and waters by 2030, and this mission has among other the objective to protect and restore marine and freshwater ecosystems and biodiversity, and also to decarbonize the blue economy. And under this mission, we have a particularly strong focus on algae, both for food, for low carbon food, as well as for regenerative ocean farming. And the Marine Board work on blue carbon can also be inspirational while we continue developing the mission to restore our ocean and waters. Additionally, a big research effort is taking place under the co-funded Partnership for a Sustainable Blue Economy, where member states bring the national funding programs to work together on common priorities, and the Commission adds additional support. And also this policy brief can be valuable for the development of this Sustainable Blue Economy Partnership. So I'm confident that this document will be very useful for us in DGRTD in considering the development of the work program of Horizon Europe from 2025 until the end of the program in 2027, and possibly also beyond and after Horizon Europe. We also hope that this work will be very useful also for funders in member states, because as the JPI in Ocean always says, the vast majority of funds for marine research, something like 85 or 90%, is not on the hands of the European Commission, but is in the hands of member states and regions. So with this, this is what I would like to say as reaction to the European Marine Board policy brief on blue carbon, and I will not take more time. I'm looking forward to the subsequent discussion. Thank you.
Thank you very much indeed. So really appreciate your comments about these documents, and it's the European Marine Board is trying to do its best to bring the information on the very important topic, and I think this blue carbon is one which is under consideration at the policy level, and we need to really follow the recommendations. So I will leave the floor now to the panel discussion and to the question and answer from the audience. And for that, we have a very nice moderator, which is the executive director of the European Marine Board, is Sheila. So it's been a pleasure to work with her. I think also for the working group. So Sheila Imans, I let the floor and to moderate for the questions and answer.
Thank you very much, Jill. So if everybody, I think the whole panel has got their videos on, right? Yeah, I think so. So thank you very much. I see that we have 2 questions in the Q&A, so we'll start with those before I go into the questions that we've discussed. Maybe it'll be a bit difficult, but I think they're not too difficult to answer. The first one is from Shengo Lee. And actually, maybe both of those will kind of be related for you, Nico. So I'll start with them. So we discussed the benefits of blue carbon ecosystems, and we mentioned the limitations about the limitations of available space. And he or she was wondering if there is any practice about for integrating blue carbon ecosystems into marine spatial planning processes in Europe. Nikos, I don't know if you know how much it's included in the marine plans of the nations. I'm not sure. Maybe it's a DG Mare question more than yours, but if you have any answer, that would be great. Thanks.
Yes, indeed, Srila. I can only speak for DGRTD, that is about research and innovation policy. Maritime spatial planning is in DG Environment and DG Mare also. So really, I don't know the plans. I cannot say about this, but what I can say is that from this discussion, from this question, I can further explore this with my colleagues. And from the DGRTD side, we can see if there is space, scope for research on this, on how to better integrate this in maritime spatial planning. Because also reading your report, I'm not an expert, I'm a fish biologist, but I'm very happy to be here. And I understood that there are a lot of difficulties that you highlight in your report for proper accounting of blue carbon, how to measure, how to show that is important, and to integrate in the strategies and policies. So this is the message I'm taking to this question, although from my position in DGRTD, I cannot directly answer to this question, so I'm taking more than giving.
Yeah, no, that's okay. And I think actually, as I understand it from DG Mare perspective, from marine perspective, I think they, all of the nations have had to create marine plans. And I'm assuming if they've included blue carbon in there, it'll be part of the blue plans. But I don't think there's any, as far as I understand, there's not really much more. I don't know if anybody else knows. But maybe we can go to the next question, because that's a little bit, or maybe it's not really quite the same thing, but yeah. So if anybody has anything to respond to that, that'd be great. But otherwise, let's go to the next question from Ingrid van Weers, who asks, what is the EU doing to foster standardization of blue carbon measurements and credit trading despite the challenges? And what are the target dates to have this challenge addressed in the EU and the world as a whole? I don't think we have anybody who can answer that, as far as I know, for the EU right with us at the moment, except if one of our panelists can. But I think Natalie said she could really address this for the UK at least. So Natalie, do you want to have a go?
Yeah, thank you. Ingrid's right. That's a really good question. And I think there's two parts in there. One is the standardization of blue carbon measurements, and the other one is sort of attaching that to the credit trading. So having that verification process based on sound scientific knowledge. Within the UK, this is something we're doing at the moment. The first part, we're looking at standardizing blue carbon measurements, and we're doing that through a number of different workshops, and this includes the devolved governments as well. So obviously the UK's got England, Wales, Scotland, and Northern Ireland. And what they've done is they collected all the people who do measurements for blue carbon and looking at the different ways and the different data, but also data that's previously been collected and whether that can be used with a view to producing a template or a methodology that really standardizes our collection of carbon, our understanding of blue carbon, not only the stocks, but trying to capture some of that flow and fluxes as well. And I think once we've got that sort of scientific robustness in collecting that data, then we can start thinking about credit trading, because I think at the moment we are not at that stage where we can fully verify any carbon offsettings, etc. So that's the UK perspective, and I'd be really surprised if there's not similar work happening in the EU countries too.
Yeah, I'm sure there is. If anybody else from the panel has anything to add, please interrupt me, but I will go on to the next question, and I'm going to also not probably ask anybody to answer it, because I'm going to make a proposal for that. So the next question again from Ingrid is, can you share development of inclusion of value of coastal ecosystems and EEZs in natural capital accounting across Europe? What progress is made in valuing ecosystem services, biodiversity, and blue carbon? I can say, Ingrid, that we did a document on valuing marine ecosystems, which actually highlighted that it isn't very far advanced in Europe. This was in 2019 or 2020, I think it was published. So, you know, more might have happened since then. But also in the coastal resilience document that Nikos mentioned, there is some work, there is some information on that, so you might want to check that out. And I will say that we have actually we're in talks with somebody who has worked on the national capital accounting, who will probably give us a talk on that specifically related to this webinar, or related to this document. He'll give us a webinar sometime next year. So keep a lookout on our website, and Torsten Thiele will probably give us a webinar on that. I will go to the next question from Kelly James, who's asking, I wonder if the panel thinks in terms of protecting blue carbon, what the panel thinks in terms of protecting blue carbon habitats. Do you think we should focus on protecting habitats that are stored carbon over thousands of years rather than focusing on habitats that sequester carbon, given their contribution may be smaller to the tropics? I guess that's what is the question. So I think in the document, I don't know if anybody
I'm happy to have a go. Yes, in fact, although I don't understand the end of the question, in fact, there are two aspects. One can protect and conserve blue carbon ecosystems, and it's a great idea to do that, not only to avoid the release of previously stored carbon, but also because of all the benefits that Nathalie highlighted. The second activity is restoration indeed, and that is also critical to regain in the coastal areas, at least, some blue carbon ecosystems which have been eliminated. So I think the answer is quite simple. One should do both conservation and restoration.
Does anybody else want to add to that? Otherwise, I think that, yeah, Natalie?
No, I fully agree with what Jean-Pierre says, but I also recognize that different countries might have different focus based on what their habitats are. And Jean-Pierre gave the example of seagrasses, like a coastal country like Indonesia that has seagrasses and mangroves. They may want to put more effort into restoring those habitats than, say, offshore sediments. So I think it will be on an individual country basis.
Yeah, indeed. Okay, then the next question is from Frederick Le Guillot. Sorry, I've got a Gilles moment there. I can't pronounce the French like he can't pronounce the German. Frederick asks, have you worked on the benefits of algoculture? I'm assuming that's algae. Do you think that beyond sequestration, the contribution to ocean pH and the substitution of petroleum-based products has a significant benefit? And could we measure it? I think I don't know if anybody wants to answer to this, to say we haven't looked at it. This was a policy brief really about blue carbon, quite specific. And I know that JPI Oceans has got a blue carbon, a bigger blue carbon project that might actually look at that. And as Nikos has mentioned, there's quite a lot of work and in Horizon Europe, specifically on algae. But if somebody else wants to add anything, Jean-Pierre?
Yes, macroalgae and specifically kelp are potential organisms that potentially export carbon to the deep ocean. Here I'm talking about natural populations of macroalgae. It is a very active area of research. It's very difficult to work on because in contrast to the other traditional kind of blue carbon ecosystems, carbon is not stored locally in the sediment. It is exported in the ocean. And so to estimate how much is exported and how much reaches the deep ocean and how much is stored for several hundreds of years or 1,000 years, it's extremely difficult to do. But this is a very active field of research. Concerning culture, artificial cultures, this is a very big topic. For example, in China, the amount of macroalgae which are grown is absolutely extraordinary. There are also attempts in Europe to do that with the benefits for food security. It's a very good use of macroalgae. Food security, the substitution of petroleum-based products is it's on paper today. I mean, I don't think there are. I have heard of flip-flops made of macroalgae, but it is not a very mainstream activity. And other companies, some startups are thinking of doing macroalgae cultures in the surface of the ocean, of course, and to dump those algae in the deep ocean. And there is a lot of concern in the scientific community of doing that, because it will lead to anoxial loss of oxygen and potentially areas without oxygen in the deep ocean. And there are better uses of macroalgae than dump them in the deep ocean. Use them for food, for example. It's an excellent idea.
Yeah, thank you. Nikos, I see you have your hand raised. Yes.
Yes, may I stress what Sheila already said, that even though we probably don't know exactly how much carbon algae sequestrate, algae are a high political and scientific priority. DG Mare has an algae initiative, and we very much support it. We have projects for algae, and together with mussels in wind farms. We have also a topic under the mission about regenerative ocean farming, that is more or less that. And also we have traditional topics on releasing or exploiting the potential for algae for all kinds of uses, not only food. And we're not talking only about macroalgae, but in some topics also microalgae that I think are more relevant for fuels. So this is what I would like to add. Thank you.
Yeah, thanks. And Nikos, while you're on there, oh, sorry, Hanso, you go first.
Oh yeah, I just wanted to add that this is linking to the field of carbon dioxide removal technologies in a way, and I think that needs to be carefully considered, as Jean-Pierre has indicated, with these, depending on where you actually dispose of the carbon, that there may be strong environmental concerns. But the field of carbon dioxide removal technologies is increasing in importance, and their activities not only for this, but also for alkalization technologies and so forth that are proposed as technologies to help the climate crisis.
Yeah, thanks. Nikos, I think the next question is also really for you. He's asking, Yo Simtanga, is asking whether the EU has doctoral scholarships for blue carbon.
Yes, the EU has a famous program for scholarships, the Marie Skłodowska-Curie, that is very attractive and very competitive. And I'm not managing Marie Curie, but to my best knowledge, is rather a bottom-up thing. So it's wide and open. So good ideas are always appreciated. And I'm sure that looking on the website of Marie Curie, the modalities can be found, and I'm sure that doctoral thesis on carbon sequestration could potentially be possible, but of course, very competitive.
Yeah, thanks. Okay, then there's a question from Phil Williamson. Hi, Phil. He asked if we could clarify whether the maximum mitigation of 2% current emissions is based on full restoration of historical losses, including the habitat loss of to coastal development that would be uneconomic to restore, and other estimates of safe and cost-effective mitigation are much lower at less than 1%, and don't take account of CH4 emissions and land-based carbon inputs. I'm not sure who, is that a Jean-Pierre question? Thank you.
Yes.
Yes. Like, I have no idea what that was.
Yes, thank you, Phil. In fact, Phil is a co-author, is the lead author of a paper we published on those uncertainties related to blue carbon ecosystems. Of course, he's absolutely correct. In the document, we used the number 2% to describe the maximum potential of blue carbon ecosystems for carbon storage. It is indeed largely based on a full restoration of the historic losses of blue carbon ecosystems, and it has 2% is at the top end of the estimates. Closer to 1% is a more realistic estimate, and I will put in the chat a link to the paper that we have a table in a paper we co-authored, Phil and I, which provide estimates, and you will see that 2% is indeed on the top end.
Yeah, so the bottom line is you know, if we do everything right, we can get 2%, but actually it's probably more like 0.5%, really, if we don't do anything right. Yeah. Okay. Then there is a question from Africa Gomez. When building carbon accounting codes, how can we account for the carbon buried somewhere else? So estimating Alakis carbon. I think that, yeah, Natalie, I was kind of looking for you. And you?
I can't give a magic answer, but this is something we talk about a lot when we consider where the carbon's come from, or toxinous, so it's come from within that habitat, or loxinous, it's come outside. And that is a big discussion about, and there's different controversial viewpoints. Some say it should be counted anyway because it's in the habitat. Others have suggested because if you're using it for carbon offsetting or carbon credits, you have to show that your management or restoration approach has had an impact and that carbon wouldn't end up in those habitats otherwise. And so it's a direct result of your restoration effort that's led to that carbon. I guess the key thing really is not double accounting that carbon. So you're not counting it where it's come from and you're not counting it where it ends up. So it looks like we've got more carbon. So not a very quick answer for you, Africa, but it's definitely something we're aware of and we need to address.
Yeah. Thanks. Then we have an anonymous attendee who's basically put in that there is actually a webinar on fish carbon this week. If I can ask one of my team to put that link into the chat for anybody else who wants to see it. It's on Thursday this week. It's really from a EU-funded project called Ocean ICU. So it might be worth having a look at that. Nikos, do you still have your hand raised? Do you want to say
It's a new one. Just to say that I know this project. It is funded under the topic on understanding the oceanic carbon cycle that I mentioned in my intervention. It is good that the project is here and advertises this event. Thank you.
Yeah, thanks. And Gilles, did you want to say something?
Yeah. I just want to have just to get an information and come back to what Nico say about the GPI Ocean, and 85 to 90% are coming from national and local fundings. And I just want to give the information that the Joint Programming Initiative, GPI Ocean, is launching a knowledge hub on the blue carbon. And it might be of interest for the people in their country to look which country will take part of that and where it will lead to some finance, as on the recommendation we will see of the policy brief of the European Marine Board, when needing funding for the research to continue what you have been presenting today. So I think just an announcement also coming back to the one there.
Thanks, Gilles. Okay, and then the last question that we have from the audience is from Samakski Devari. Sorry. So here they ask, you spoke about restoration of some of the blue carbon habitats. Could you comment on how long in time do some of these habitats take to be restored functionally? That's a great question. Jean-Pierre?
Yes, I'll give two examples. The first one is the mangrove of Mekong Delta across Vietnam and Cambodia, which has been 56% of it disappeared as a result of what the US calls the Vietnam War and the Vietnamese call the American War, due to the use of napalms, for example, and pesticides. So in 20 years, this mangrove has been largely restored due to local actions. It must be said that mangroves are the easiest blue carbon ecosystems to be restored, but in 20 years, 2,700 square kilometers of mangroves have been restored, which is remarkable. And interestingly, the restored mangroves have a carbon content in the sediment that is similar to natural mangroves. So it's very reassuring. The second example is the San Francisco Bay. A very large salt marsh has been restored in San Francisco Bay. It took 10 years to have it fully restored. So it can be very fast. There are some species for which it is much more difficult. For example, Posidonia oceanica in the Mediterranean grows very slowly, and so it will take almost forever for such seagrass beds.
Yeah, thanks. Okay, if there's no other answers, then I'll go to the questions that we discussed from the beginning. So I'll start with Hans Otto, actually. And I guess, Hans Otto, I know that you probably will be at the COP in the UNFCCC COP in I don't know where it is now, somewhere in the Middle East.
Dubai.
There we go, Dubai. Thank you.
Yeah.
So what would you say would be your most important message that you will take from this document to that meeting?
Well, the most important message is actually fully in line with also a message coming from looking at land ecosystems and sort of the green carbon stored there, that the rate of carbon storage in natural ecosystems is too slow to compensate for current emissions, and that every effort to sort of in the budget to sort of make up for current emissions by using blue and green carbon ecosystems is in vain. So it's really a matter of time scale. This is one point. The short term must be the cutting back on emissions fast and strongly in order to keep to the Paris Agreement.
Yeah.
And this is already a big question. And the second is, however, that these long-term trends in terms of carbon storage in natural ecosystems are very, very important for long-term climate stabilization, such that the restoration is a very important effort. And it's also a warning, because global warming is damaging those systems, and it is a no-brainer, as Jean-Pierre has already indicated as well, that for biodiversity conservation, conserving carbon-rich ecosystems both on land and in the ocean should be a high priority to meet the targets of both the CBD and the climate COP.
Yeah. Thanks. And then I'm going to go to Peter, and it's actually a kind of a continuation from what Hans Otto just said. Because, you know, we say that the ocean is currently absorbing 25% of the greenhouse gas emissions, but we also highlight that the uptake will diminish, you know, with more CO2 being dissolved into seawater. So how is the ocean's uptake and release of CO2 linked to the greenhouse gas emissions? How is that happening?
Yeah, I think we got very accustomed to that number, to this 25%, because it's been true for many years and many decades. So the ocean has always been our faithful friend that was sort of helping us mitigate the climate crisis. But if we, for example, look in the future, we are sort of at the crossroads, right? I mean, whatever we do, you know, in the next year, sort of will, you know, eventually, determine the future climate. And if we, for example, take the path that we are on now, that we continue business as usual and we start to emit enormous amounts of carbon dioxide, we know that the ocean will not keep pace. This 25% might be true now, and actually the global carbon budget, one of the sort of the biggest annual sort of assessments of the carbon cycle, from which also our figure was essentially drawn, already stated that today we already have a sort of a 4% reduction of the capacity of the ocean to take up carbon, and that will sort of increase in the future. So eventually, as we see in a sort of continue as usual, or continue as we do right now scenario, where we continue emit CO2 until the end of the century, we see that the ocean uptake will diminish. We'll see that it will flatten off. That is obviously one possible future. Now, that's not the future we're hoping for. There's also other futures where we sort of reduce our emissions. And essentially, as the ocean uptake of carbon dioxide is essentially dependent on the gradient, or the difference between CO2 in the atmosphere and the ocean, this uptake will equally reduce, but it will sort of follow sort of pace with the atmosphere in that sense. There's other options. We've talked about carbon dioxide removal, for example, and sort of wanted to sort of mention this one as well. Say, for example, we would remove large amounts of carbon dioxide from the atmosphere. We know that the ocean might actually turn from a friend actually into a foe, because the carbon that is currently stored at the ocean might sort of be re-released into the atmosphere if the concentration essentially if the ocean becomes undersaturated in terms of carbon dioxide. This is something that we, for example, see in places where we already see ventilation from deep waters into the surface, where old sort of carbon-rich waters resurface and the ocean becomes super saturated in terms of the atmosphere. And so we see that the ocean can also degas carbon dioxide. So there's sort of many potential scenarios that we can think of. But I think what's most important is that we have to reduce emissions. That is the sort of the key point that is of most essential.
And that's also what Hans-Otto was just saying, right?
Yeah.
Okay, then Natalie, a question for you. What are the main factors that are affecting carbon uptake in the kind of habitats that you work on, the blue carbon habitats? What are the main impacts?
I guess if we think about coastal habitats, it's really down to the plants, the plant diversity and what type of plants we have there, and also how healthy the habitat is. So if it's a healthy habitat, you'll have your different gradients, your different plant species diversity as you move across that salinity gradient. And each of them are slightly different in how they take up and store carbon. If we think about things like mudflats, they'll be down to the micro producers, the microalgae, the microphytobenthus, and the surface sediments. And then there's a difference when we talk about blue carbon, we talk about carbon uptake, but the uptake is one of the processes, and that's the taking up of the CO2 directly through photosynthesis from the air. But what we're really interested in is that sequestration, and the factors that influence that are hugely variable, and we're still really understanding it. We have a pretty good understanding of what's happening on the coastal systems. We don't know a huge amount in terms of detail, variability, site specificity. We do know there's certain areas we need to look at, such as the greenhouse gases, the role they play and how that influences the sequestration, whether that's linked to restoration, health, salinity. So are we seeing a change in the methane and CO2 emissions as we go seasonally or up and down the coast, etc. So that's a big gap of knowledge. And then further offshore, we know very little. Obviously, most of that carbon has come elsewhere, but we're slowly starting to understand perhaps the variability and how long it takes to accumulate, which is a long time, very, very long time. But the threats to them through human activities such as dredging or man-made structures such as renewable structures in the environment, we don't fully understand that and those dynamics just yet.
Thanks. And then maybe we'll go on to Jean-Pierre about more understanding more of these uncertainties. If you had to pick one, what do you think is the main uncertainty that we need to tackle to have blue carbon as a climate change solution?
Well, that's a difficult one because they are potentially, all those uncertainties are potentially important for carbon offsetting and crediting. Perhaps a better understanding of the carbon stored, the rate at which carbon is stored in the sediment. I think that will be a big one to close. I mean, a big knowledge gap to close. I know that there are colleagues trying to work on using new techniques such as artificial intelligence to try to have a better understanding on the flow of carbon storage in the sediment using proxy variables. I don't know whether it will be successful or not, but it's an important aspect of research to look at. For example, I mean, for the carbonate chemistry, we have been astonished to see how much progress has been made to understand the carbonate, the chemistry of the carbon dioxide system, if you like, in seawater, and artificial intelligence are improved estimates quite considerably with a small number of simpler variables to measure. So there is potential there, and I hope progress will be made shortly.
Yeah. Thanks. And then Nikos, we've got some questions for you too. The first one, what is the most important message that you have taken from this document? I guess you mentioned it before, but maybe we will, if you can.
Yes.
Yeah.
Thank you, Sheila. So in terms of marine policy, the most important message, I think, is that despite the uncertainties around the magnitude of climate benefits of blue carbon, and what is the global carbon sequestration potential, it is clear from the report of the Marine Board that there is no reason not to protect them. On the contrary, it's very clear that conservation and restoration of blue carbon ecosystems is a low regret action, with very few, if any, benefits. This is the overall message I get, but speaking more in terms of research and innovation policy, because this is what we do in the DG RTD, I would say that the most important messages come from the recommendations at the end of the Marine Board report, the recommendations to support research to quantify the possible production of methane and nitrous oxide that might arise from coastal restoration efforts in the long term, and also to study the impact that this might have on greenhouse gas emissions, and also the encouragement to fund research to understand the dynamics of offshore carbon stocks and sequestration and the possible impacts of human activities. This is a clear research policy message, and I see that in this report it mentions that human activities trawling, and I'm very happy to say that we already have an open topic on climate change and fisheries, where among other issues it touches clearly upon the resuspension of carbon sediment by bottom gears. And for this, we explicitly say that projects that will be funded under this topic have to create synergies and collaborate with the ICU ocean topic that was mentioned before, funded under the blue carbon understanding, the blue carbon cycle. So there is the policy message that we should take action, even though we don't know exactly the numbers, and more concrete research policy issues on what kind of research is needed. So this is what I'm taking mainly or primarily from this report. Thank you.
Yeah. Thanks, Nikos. I see there's a follow-up question from Samski Tiwari again on the question about mangroves. I think that was to Jean-Pierre. He says, could you explain why mangroves are the easiest of blue carbon ecosystems to restore?
Yes, I'm happy to do that. The reason is that the natural reproduction of mangrove trees is flowering. So flowers are pollinated by insects and by wind. And once there is a seed, the seed stays attached to the tree for a while, and then it drops down on the floor. So what needs to be done is just to collect those propagules and grow them for some time, not for very long, on land, in plots, in pots, like you can do in your garden, and then to transplant them in the sea. So it's very easy. There is no high-level technology involved. It needs a lot of manpower, though. But in countries such as in the tropics, where mangroves are located, very often that the local population is also very happy to restore their environment, and there is a community contribution to mangrove restoration.
Yeah, and I guess in those kind of situations, the restoration is by and large more for habitat provision. I mean, if local communities are involved, it'll probably be because it will improve their fisheries, really. But you know, the co-benefit is that it's actually good for climate change. I think that's the difference between that kind of situation and what might be restoration in Europe, which would be probably for different reasons, I imagine. Then we also have a question from Rupesh Bomia. Many blue carbon ecosystems also exist in countries which does not have great technical capacity to develop data sets or reduce uncertainties or fill knowledge gaps. So he's wondering whether the Marine Board has also deliberated on how to reduce the disparity and enhance the capacity of these countries to best take care of their ecosystems with local capacity. Yeah, I'm just wondering how best to build this capacity sustainably. I guess that kind of follows on from my comment just then. I don't know if it wasn't part of the document, but indeed it is, of course, a very different situation in countries that don't have the capacities to do the research as maybe in Europe. I mean, even in Europe, I think coastal communities or coastal ecosystems haven't necessarily always had as much research as others. So I don't know if anybody has a comment on that or want to answer that. Nikos?
Yes, it's not exactly a research question, and but I happen to know that For example, our colleagues in DG INPA, former DEFCO, who are dealing with international partnerships on helping countries to develop. I remember that I often see projects that are not scientific, but about restoration of mangroves, for example. So I'm sure that this is in the radar since quite long of our development colleagues. And this report, although it's not targeting this Directorate General, could also be useful for such partnerships. So it's something that maybe even the authors have not thought of it.
Yeah,
so
yeah.
it's a question, I think.
Yeah, maybe we should talk about that afterwards, Nikos. You can give me the right names to make sure that they have the report. Yeah. I guess I have a follow-on question for Natalie, a little bit. Maybe it's not quite, it's a bit tangential. I mean, we talk a lot about mangroves and they're kind of easier to restore, but I guess different blue carbon habitats have, store different amounts of carbon. So do you have some idea of how different that is?
I think mangroves are seen as the one that has the most, followed by salt marshes. But again, that very much depends on how old that habitat might be, how healthy it is it degrading, that sort of thing. What are the other pressures on it? How is it going to change with sea level rise? And then, of course, within that, if you're looking at restoration, there's different restoration approaches. Obviously, I don't work in mangroves, but we have a lot of seagrasses and salt marshes here. And there's different scales of things, from small local land stakeholder sort of land owners approaching to do the small scale things to the larger scale things, such as the Project Seagrass, where they're actually taking seeds of the seagrass and then replanting them out. So different scales of different restoration projects, which is really good to see. I believe there is in the process in the UK a review at the moment looking to understand which restoration efforts are most effective. And then I guess the caution with that would be in terms of the benefits for carbon, those are going to be a lot more of a longer term scale, and Hans Otto referred to that. We're sort of investing in the future by establishing them, but we'll see a lot of the co-benefits such as biodiversity, coastal protection, etc., a lot more immediately.
And then maybe I'll go to Hans Otto now that you mentioned him. Hans, what is the most important gap in relation to blue carbon and climate change? A gap in knowledge, do you think?
Well, the most important question certainly is long-term survival and stability of those blue carbon systems in terms of maintaining their biodiversity. As climate change is progressing, we are loading these organisms with thermal stress, and the thermal habitat of the species concerned is changing, and heat limits are being surpassed. We see that especially in coastal ecosystems. Marine species are on the move. So biodiversity in sediments is changing. Biodiversity in mangrove systems is certainly also changing. I'm not aware of too much research actually on that. And in that respect, I think there is high uncertainty currently that with current humankind's failure of missing the climate targets, that these systems are damaged in their capacity to store the carbon to the extent that we would wish them to do. And this is, I think, the largest challenge we are facing. There needs to be more research, and these arguments need to be brought to the attention of the policymakers as one of the lines of reasonings that is really stimulating them to take ambitious action and not compromising with those targets in their daily policies. Thank you.
Thanks. I think we only have 2 minutes left, so I'm going to ask the last question to Nikos. So Nikos, how do you think will the EU or the European Commission at least address the uncertainties before we use blue carbon ecosystems for EU-wide voluntary framework for high quality carbon removals? Do you think I don't know, it's a difficult question, but do you have, I don't know if you have any answer to that?
Thank you, Sheila. I will again speak mostly from a research and innovation perspective. And I would say that we will take, of course, into consideration the report of the Marine Board, and particularly the recommendation to further support research to reduce uncertainties about the amount of carbon removed and stored by blue carbon ecosystems. And it is obvious that this is essential to have a reliable science-based crediting and offsetting systems. And so this is what I can say from a research side. And already, as I said, Horizon Europe supports several projects on oceanic carbon cycle, on ocean and coastal carbon and biodiversity rich ecosystem, on wetlands. And of course, let me again say, although this is not exactly the reply to the question, because the reply to your question is that in DGRTD, we'll see if we can help with better, we're reducing uncertainties to better monitor, to better count carbon and fluxes and removals. That again, we have the mission that to restore our waters and oceans by 2030. That is the new thing to do research not only. And we have the objective to protect and restore marine ecosystems and biodiversity and to decarbonize the blue economy. So maybe it fits, certainly fits there. Maybe it's the best place to place it. And let me remind you that in order to do this decarbonization restoration, we count on an enabler called the Digital Ocean and Water Knowledge System that is about data, and data and the digitalization of data is also key to reduce uncertainties about the role of blue carbon in global carbon sequestration. So as far as data and research is needed, we will try to do our best.
Thanks.
This is what I can.
Yeah. I see Jean-Pierre has his hand up, and then I
Yes.
think that will be the end for us. Thanks.
Yes, very quickly. I just want to clarify something. There is already a standard for blue carbon ecosystems, for carbon crediting. It is made by a company called Verra, V-E-R-R-A, and it has been revised in July this year, 2023. But I don't think it addresses all the sources of uncertainties that we have been discussing. And I want to be extra careful because a Verra standard was heavily criticized for land forests. This year, lots of scientific papers in the media, which showed that this standard for land forest was in fact deficient and led to many over-crediting. So we need to be very careful to have a honest crediting system.
Yeah.
Thank you.
Thanks. I think that's a good place to end. I think we definitely have a lot of uncertainties, and we need to make sure that we get it right, because this is too important to get it wrong. I think I'll leave it at that. And I'll hand back to you, Gilles.
Okay, thank you very much for the moderation and the good type of question and answer. So to conclude, I will say what I take. So I'm not a specialist in the domain, but what I understood that is the rate of carbon sequestration and storage is quite modest, but the blue carbon solution is really important to pursue, especially if we want to contribute to the climate stabilization. Whether it is coastal or offshore, I think this is important. I think we have retained also they have many valuable co-benefits. We knew that they can be used to protect harbor or coast against flood, storm, or action like that. I discovered recently that the mangrove that is for Jean-Pierre, what he say is an example of a viviparous plant. I didn't know that, so this is something of interest just for our knowledge. And I will say that for the recommendation that was in the document, we came to the fact that we still have to support observation, and this observation is for all marine understanding. And we have been working hard to have observation, and especially now we have to better observe and know the processes for the carbon cycle models. And for that, it's important to have this observation if we want to monitor and know what is the flux, the carbon stocks, and all that. And I think this is something important in that direction. And for the European Commissions, but not only for our national and local society, we need always to fund the research to reduce the uncertainties, to quantify the possible production. It's been said a lot of time, the production of methanes, of nitrous oxide. This seems very important, and that's been said many times, that we have to fund this research and continue to understand that, and to understand the dynamics of offshore carbon stocks and sequestration, and of course to understand the impact of human activity, especially today. It's quite important to know what will be the impact from the deep sea mining, because we have many countries, we are looking for deep sea minerals, especially with the new willing to have this mineral, and especially the minerals for the transition, economic transitions, for electrification, but also with the troll fishing, which is also removing the sediments in the side. And moreover, this is like the ODD 17, which is partnership. We need collaboration, and we need collaboration between different scientists from environmental. I'm a geologist by skill and by formation, but working on the sediments, but we need engineer, we need scientists, and for the blue carbon solution, all these people are needed for the integration. And I would like to thank you all for your presentation and for the work you have done in these working groups, and for the nice document which has been produced and make the European Marine Board a very active and in the front for that. And I just want to recall that you can have access to the blue carbon challenges and opportunity to mitigate the climate crisis, which is accessible on the internet, on the www.marineboard.eu website, and you can scan and you have direct access to that. So thank you very much to all. And I think with that, I close with 1 minute late, I think, the webinar. Thank you to all to your contribution. Thank you.